So what we want to treat is series and sequence. Now what we need to do is to first understand what a sequence is. A sequence is a succession of terms in a way that the terms are related to one another in accordance with a set of rules. So a sequence is a succession of terms in a way that the terms are related to one another in accordance with a set of rules, meaning there is going to be a rule that is set for you to use to set the terms. Now, one thing you need to note here is that the rules of engagement in the pattern of the terms may differ, meaning you don't have to have the same rules for all different patterns. So if you're going to have different patterns, it means you have to set different rules for it. Now let's take for example e.g. when you have 5, you have 11, you have 17, you have 23. Now the rule that is being used here is addition of 6, meaning if you have one number, just add 6 to it for you to be able to get the next number. Now the following one is, assuming we have 1, 3, 9, 27, then 81. So the set of rule that we used here is 3n minus 1. That is what is being used. Now let me give you an example. If my first time, that is the first one, I want to get the first one, which is this one, I'm going to say 3 raised to power what? 1 minus 1. If you look at it, it will be 3 raised to power 0, and anything raised to the power of 0 will give you 1. Now let me set for the second one, which is 3, that is 2 minus 1, meaning 3 raised to power 1, and anything raised to the power of 1 will be that same number. Now let us get for the third one. Let me clean this first. Now for the third one, you still have 3 into 3 minus 1, meaning 3 raised to power 2, and 3 raised to power 2 will definitely give you 9, and 3 raised to power 4 minus 1 will give you 3 raised to the power 3, and 3 raised to the power 3 will give you what? 3 raised to the power 3 will give you 27. And the same thing, if you still go on, you get 81. And that is how that is actually gotten. You can see that a set of rules is actually meant for this, and that is why we are able to use that set of rules to get what we have done here. Now let's clear this and move to the next one. Now let's see the examples that are given here for us. They say that example 1, if they give my rule to be, they said the nth term of a sequence is given by 3 times 2 raised to the power of n minus 2. Now they want us to write down, the first 3 terms. Now let me explain the question now. They said the n times of a sequence is given by this rule, meaning multiply 3 into 2n minus 2. Now they want us to write the first term. Now the rule that is being given to us is this: 3 times 2n minus 2. So for my first term, which is 1, it means wherever I see n, I'm going to represent it with 1. So I'm going to say 3 times 2, this is n, so I'm representing it by 1 minus 2. Then I'm going to work this out by saying 3 times, now 2 raised to the power of, that is 1 minus 2, that will give me 2 raised to the power of minus 1, because I'm having 1 naira and I have to give somebody 2 naira. Even if I give that person 2 naira, I will still be left with 1 naira deficit, and that is why this one is minus 1. Then I'm going to have, now in the rule of indices, when you have 2 raised to the power minus 1, what it means is 1 all over 2. So when you now multiply 3 times 1, it will give you 3, and when you multiply 1 times 2, it will give you what? 2. So that is why this first term will be 3 all over 2. Now for the second term, which is 2n, that means wherever I see my n, I'll have to substitute it by 2. Then times, now look at this, 2 by 2. Now 2 by 2, that is 2 minus 2 will give me what? 0. So I'm going to have equal to 2 times 2 raised to the power 0. Now anything raised to the power of 0 will give me what? 1. Then I have to say 2 into 1, that is 2 times 1. Then 2 times 1 will give me what? 2. Did I get this at all? Let me try and see. 3 raised to the power, okay, it is 3 that we have here now, Abby. It is 3 that we have here. Now it means this will be 3, then this will be 3. This is anything raised to the power of 0 will give me 1. 3 times 3 will give you so. Then for the last one, which is C, this, meaning 3 times 2 raised to the power what? 3 minus 2 equals to, this n is this n, as in this 3 is this n that was, and this 2 is this 1 that we have here. So I'm going to say 3 times let's say 3 minus 2 will give us what? 1. So I'm going to have 2 minus 1. Then I'm going to have 3 times 2, because 2 minus 2 raised to power 1 will give you 2. Then you're going to have something like 6 for this next term. Now let us stop here and see what we've done so far.